Square roots do not exist everywhere. If you have a negative underneath the square root, it's going to be imaginary, and you cannot graph imaginary numbers. So we have to be careful about what x's we're putting underneath. This thing will not exist everywhere. So what we have to do is we have to figure out where it exists. So we have to find the smallest number. What is the smallest number that you can take the square root of? What's the smallest number that you could put under a square root and get a number that's not imaginary? 0. So the smallest number that would actually provide something for a graph would be if we had the square root of 0. So the first thing we have to do is we have to figure out what makes the innards of the root 0. So we have to set whatever is in the root equal to 0. And that's going to tell us where the graph goes from not existing, giving us imaginaries, which we can't use, to actually starting to exist on the graph. So we have to now solve for x, kind of similar to what we did with absolute value graphs, where we had to find that bounce point at the beginning. That was chapter 2. And so when I solve this, I get negative 4/3. So this graph starts to exist in the real world at negative 4/3. So that's our first x on our table. And when I then put that in to the equation, kind of like plug and chug, I'm going to get a 0 underneath the root, because that's what I just figured out. What would I put in? The whole point of doing this was to put a number in to get 0. So the square root of 0 is 0. And now we have to figure out where we're going. So we need to pick a number close to negative 4/3 to see if it works. So I'm going to choose negative 1. I'm going to put negative 1 in for x. And if I get something real, I'm on the right track. I'm going the right direction. If I get something negative, which would lead me to a square root of a negative, which is imaginary, I need to go the other direction. So when I put in negative 1, I get 3 times negative 1 is negative 3, plus 4 is 1, the square root of 1 is 1. So I'm good. I'm heading the right direction. So if I plot these 2 points, negative 4/3, 0 is right there, that little green dot that I've put on my xy axis. That's where this thing starts. And negative 1, 1 is right there. Before negative 4/3, 0, there was nothing. There's nothing happening. This basically the start of everything in terms of this graph. Okay? And so now what you do is you make up whatever numbers you want in the x column that are on your graph paper to figure out where this graph's going to go. All right, you can just go in order, 0, 1, 2, 3, 4. You can use decimals for the y's. I have no problem with that in this section because a square root's going to lead to some decimals. Or you can find ones that are going to work out nicely. All right, so that orange dotted line basically signifies the start of things. Yes, ma'am?
So I would negative 4/3 be over like 1?
It's negative 1 and 1/3.
Okay.
So it's negative 1.3.
Oh, okay.
So I'm going to, in the previous hour we chose 7. It really doesn't matter what you choose for the x. 7 works out nice. 3 times 7 is 21, plus 4 is 25. Square root of 25, 5. So 7, 5 is on our graph, which is way out there. If you want to just go in order, like I said, you can. There's no problem. Somebody else suggested we go 4. So we went 4 and got 4, 4. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. So that's where you get your y coordinate of 4. That's right there. All of our graphs are going to look like a sideways half parabola. I tested 11 too, and I got 6-point small decimal. I don't have a calculator, so I don't know exactly what the decimal is, but I got 6-point small decimal, which is up here. And then I just draw the graph. So this thing springs out of nowhere and starts going.
This might be a really stupid question.
So my next question is, let's bring back an old topic. What is the domain of our graph? Yeah. So where do you see green from left to right? From -4/3 and up. So we would write that all x's greater than or equal to -4/3. Very good. And then the range would be, where do you see green vertically? From 0 up. You've got to be able to take the concepts from previous chapters and just apply them. That way, you don't have to relearn them every chapter. There's really nothing in this problem that you don't already know. It's all stuff you already know. All right. I want you to try this one and see how far you can get without me saying anything. All right, so my x value is 3/2, my starting point. And when I put that in, I get a 0. You don't always get a 0, which you'll see next example. You do in this case. I'll show you next example. And so then, now you just make up some numbers. Like I said before, I put in a 2, I get square root of -1. Well, that's imaginary. So I'm going the wrong direction. So instead of getting bigger with my x's, I need to get smaller. So I drop down to 1, which works. And then I just kind of found some more. Here's an example of some of the ones I found. I went 1, 0, -1, -2, -3, and -10. You might have those. You might have different ones. It doesn't really matter as long as they're accurate. Okay? You can see my decimals there. 1.7 for 0. 2-point small, or 1.7, not -1.7. All right, so 1.7, 2-point small decimal, 2-point big decimal, and then 4-point big decimal. To graph those, there. So I got an idea of what I was doing, and then I made one out further to see where I was eventually headed. And then I draw my graph. So your graph should look something like that. The domain, x is less than or equal to 3/2. Make sure you have less than or equal to. And the range is y is greater than or equal to 0.
So the barrier.
All right, I want to show you this one now. And what makes this one different is we are shading, because it is an inequality sign. Now, there's really nothing else to this except all the stuff you've always known about shading. So it doesn't add any levels of difficulty. If you understood shading before, you should understand this. To get started on this one, I'm going to set the inside of the root equal to 0. What's different about this one is there's a 1 on the outside, which is going to change several things about this. Notice I did not bring the 1 over when I was setting it equal to 0. The only thing you set equal to 0 is the innards of the root. You did not bring the 1 with you for that part. Okay? So setting 6x minus 2 equal to 0, I get a x value of 1/3. So that's my first x. Now, here's where we don't get 0 in the y. When I put 1/3 in, I get 0 in this orange area. 6 times 1/3 is 2. 2 minus 2 is 0. But 0 plus 1 is 1. Okay? Any superfluous numbers outside the root sign are going to change that 0 that you've been getting for the first few examples. Okay? So my born-on point is going to be 1/3 comma 1. Now I'm going to make up some x's. Whatever x's you want, it doesn't matter. All right, I'm going to go through mine quickly since kind of running out of time. So there are my points that I made up. 1, 2, 3, 8, 12. 1 was 3, 2 was 4-point small decimal, 3 was 5, 8 was 7-point big decimal, and 12 was 9.5-ish. Okay? And those are the ones I'm going to graph to see my half sideways parabola. Okay? We're going to graph this. So there are my points. And this is a dotted graph, bringing back some of our shading rules. It's a dotted graph because the inequality sign did not have an equal. Now we have to find a point to test to see whether we're shading above the line or below the line. One rule that's kind of new is that when we shade this, we're only going to shade it in the area where the graph is alive. If you think about my example about the graph being born, in this area here, pre-graph, that doesn't get any shade at all. We're not shading there at all. You're only shading below or above on the right side, only in the existing part of the graph. You might as well cut your graph paper on that line because the graph didn't exist. The graph wasn't born. Okay, so nothing happens left of this graph. So we have to pick a point right of that dotted line. So we can't pick 0, 0. And you'll know that if you try. Because if you put in 0, 0, you're going to get an imaginary number on one side and a real number on the other side. And you can't compare an imaginary and a real number. It doesn't make any sense. So an earlier class selected 4, 4 as the point they wanted to test. Okay, so we'll go with that. When you put in 4, 4 into the inequality, you get 4 is less than the square root of 6 times 4 minus 2, and then that plus 1 on the outside. 6 times 4 is 24, minus 2 is 22. Square root of 22 is 4 point something. And 4 point something plus 1 is 5 point something. So now what I'm looking at is 4 is less than 5 point something. Is that true? Yes. 4 is less than 5 point something. So our 4 point is true. So we shade below the graph in the area where the graph exists. Which would be that area, yeah, all the way down. What?
The chair broke. I went for like